Let's have a look on the following exercise, which is quite similar to the one we have done in this chapter about digitization. The main difference is we do not have one single connection, but we have several connections in a row. So we have a Wi-Fi connection, then we have a DSL connection, then we have a T1 connection, and we have a WCDMA connection. All of those have different bandwidth. So if you would like to draw these connections, you would have something like, okay, first that's Wi-Fi, then we do have DSL, then we do have T1. That's a connection which is used in the data highway, which is very fast or it has a very high bandwidth. And finally, we do have wideband CDMA. That's a connection which is used for mobile communication. Basically, it's not used anymore, but when I have designed this exercise, it was still in use. So the question is, what is the overall bandwidth? Yeah, so of course you could now approach the exercise with different assumptions. For example, we could take the average and so on and so on. But this issue is the overall network, the bandwidth of the overall network is determined, is specified by the smallest bandwidth. Okay, so first thing we have to do is check for the bandwidth of each of these connections. Yeah, then choose the minimum one. In German, we have a proverb which says a chain is as good as the weakest part in it. And this is basically the same in here. The network is as slow or has as small bandwidth as the weakest connection. Now let's check. Okay, Wi-Fi, we have to look up, but basically we have typically values like 10 megabit per second. Yeah. DSL, basically the same. Maybe we have 8 megabit per second. T1, that's the data highway. Here we are going for gigabyte per second. And the weakest part is WCDMA. Here we do have maximum 368 kilobit per second. So that's what we need. And now we can do basically the same calculation as we have done in the other exercise. So we do have, 10 megabyte divided by 384 kilobit per second. Yeah, and then we have to normalize it as we did it before. So this is 10 times 1024 times 1024 times 8 divided by, here we have bit now, divided by 384 times 1000 bit per second. Again, why that? That's mega when it comes to file size. That's 8 bit equals to 1 byte. And this 1000, that's kilo. Kilo when talking about throughput, bandwidth, etc. And of course we can simplify, put the units, put the bits away, put the second in here, and we end up with 10 times 1024 times 1024 times 8 divided by 384 times 1000. I directly put it like this, seconds. And now again, make use of the table calculator. So what do we have? We have 10 times 1024 times 1024 times 8 divided by 384,000. So what we have is roughly 218 seconds.